Alright, so here's the question. There are two trees that are 7.5 meters apart. The backpacker is trying to lift his pack to get it out of the reach of bears, and they want to find the magnitude of the force that he must exert downward to hold the 15-kilogram backpack so that the rope sags at the midpoint by 1.5 meters. And here is a little drawing I did to try to illustrate the problem. Here are two trees. There are 7.5 meters between them. Let's pretend like this is the midpoint, although I know it's a little bit askew. And the backpack is 15 kilograms. It's hanging out there. And there's a guy pulling down this way. That's the force we're trying to find to keep the backpack there. Alright, so he's got it rigged up so that the other tree will do some of the work of lifting, and we need to find the work that he's doing to lift. So the first part of this problem is to realize that it's a triangle problem, really. So you have to draw a little picture of a triangle, a little simplification. So let's simplify this to just what the backpacker is doing. So this is his side of the operation. So he's just doing that pulling there. He's pulling this down here. There's a weight in the middle. You could have also drawn it. Maybe this is better. Like that. He's doing the pulling here. There's an object over here that's being pulled. And we have the two sides of the triangle, so we can figure out the force. So they tell us that the trees are 7.5 meters apart and the backpack is at the midpoint, so that means the midpoint is 3.75 meters. And I'm not going to use units. And they say that the distance that the backpack is hanging or sagging is 1.5 meters. So you go, okay. So this is 1.5 meters here. Alright, now this weight is 15 kilograms. And the force acting upon it is gravity, which is 9.8 meters per second squared. So you multiply that, and you get 147 newtons. Now, because he's got this rigged up so that the other tree is doing some of the work, he doesn't have to do all the lifting. He only has to lift half of this thing. So you take the 147 and you divide it by 2. Okay, so that's what he's lifting, 73.5 newtons. So if you want to clarify your picture, this is the triangle he's working on. It's not a very efficient way to lift something vertically because he's losing all of this in the horizontal. So we need to find out how much force is actually being exerted to lift this 73.5 Newton object. Alright, well, it's not at a great angle. It's at a pretty small angle, and as the angle decreases against the vertical, right, the amount of force that it requires to lift something vertically increases. So we need to find the angle here. So you use tangent, opposite over adjacent, and so you do tan 1 of 1.5 over 3.75, and that will give you a degrees of 21.801 degrees. So that's this here, 21.801 degrees. Okay, so the total amount of force needed is 73.5 newtons. but he's lifting it at a weird angle where he has to exert extra force because there's this horizontal component. So how much is in the vertical component given that there's a horizontal component? Well, we're interested in the vertical, that's the opposite, right? And we know what the hypotenuse force is. That's the 73.5 newtons. So we can use sine to figure out what the vertical force is. So sine is opposite over hypotenuse, right? So we rewrite that. So you have this divided by sine of 21.801 degrees, and that will give you the force in the vertical. So 73.5 divided by sine 21.8 is 197.9 newtons, and that is the answer.